Most probably, if you're using a smartphone, the touchscreen is capacitive, means it uses several capacitors which you actuate with fingers. All memory systems, including these phones and all computers, use capacitors for binary memory systems. All fans, water pumps, fluorescent lights use capacitors. You use radio and TV, which you use then in large numbers. Selections of stations or channels on these TV or radios is based on capacitors. But wait! What is a capacitor? What is capacitance? What is dielectrics? So, let's learn! A capacitor is a device that has the ability to store some electrical energy, and it is purposely designed to store large amounts of electrical energy. A typical capacitor consists of two conducting surfaces, separated by an insulating material like air, rubber, or paper. This insulating material is called a dielectric.
Dielectrics and capacitors serve three purposes. First, to keep the conducting plates from coming in contact, allowing for smaller plate separations and therefore higher capacitance. Second, to increase the effective capacitance by reducing the electric field strength, which means you get the same charge at a lower voltage. And lastly, to reduce the possibility of shorting out by sparking, or more formally known as dielectric breakdown, during operation at high voltage.
The capacitance of the capacitor tells you how much charge it can store when connected to a particular battery and is measured in units of farads. So it can be determined by measuring the amount of charge stored on each plate when it is connected to a battery with a certain voltage. The formula is capacitance equals electrical charge over voltage. So here is a sample problem. What is the capacitance of a capacitor with a given electrical charge of 3.47 times 10 raised to negative 6 coulombs and a voltage of 4.50 times 10 raised to negative 3 volts? Let's solve. So 3.47 times 10 raised to negative 6 coulombs over 4.50 times 10 raised to negative 3 volts equals to 7.71 times 10 raised to negative 4 coulomb 4 volts, which is equivalent to 1 farad. So let's go on to capacitance in series. Capacitors connected together in series have the same charge regardless of its capacitance. The connection of capacitors is positive to negative. The formula is 1 over total capacitance equals capacitance 1 plus 1 over capacitance 2 plus 1 over capacitance 3 and so on and so forth. Here is an example. Capacitance 1 is equals to 60 nanofarads. Capacitance 2 is equals to 80 nanofarads. Capacitance 3 is equals to 10 nanofarad. What is the total capacitance? Let's substitute. 1 over total capacitance equals to 1 over 60 times 10 raised to negative 9 farads plus 1 over 80 times 10 raised to negative 9 farad plus 1 over 10 times 10 raised to negative 9 farad. Equals 7.74 times 10 raised to negative 9 farad. Now let's go on to capacitance in parallel. The voltage connected across all the capacitors in a parallel circuit is the same. So capacitors in parallel have a common voltage. The connection of capacitors in parallel is positive to positive and negative to negative. So the formula is total capacitance equals to capacitance 1 plus capacitance 2 plus capacitance 3 and so on and so forth. So now let's find the total capacitance of capacitance 1, 3 microfarad, capacitance 2, 6 microfarad, capacitance 3, 9 microfarad. So let's solve. 3 microfarad plus 6 microfarad plus 9 microfarad equals to 18 microfarad, which is also equals to 1.8 times 10 raised to negative 5 farad. That's all. So let's get a review. So capacitance is equals to electrical charge over voltage. 1 farad is equals to 1 coulomb per volts. Capacitance in series. Formula: 1 over total capacitance equals 1 over capacitance 1 plus 1 over capacitance 2 plus 1 over capacitance 3 and so on and so forth. Capacitance in parallel. Formula: total capacitance equals capacitance 1 plus capacitance 2 plus capacitance 3 and so on and so forth. That's all. We hope you learned something and apply it. God bless us all.